if you'll recall, finding zeros is simply finding the x points on your quadratic graph that intercept with the x-axis, or where y equals 0. Okay, so the zeros of this quadratic function would be there and there. Okay. Let's say we're given the following quadratic function: x squared minus x minus 6 equals 0. It's important to note that you always want to set one side of the equation equal to 0 when you're finding zeros, as in y equals 0 or f of x equals 0. It means the same thing. Okay, so this equation just happens to factor fairly easily. And we'll go ahead and set it up. So factoring would mean separating it into two factors, where here's a factor and here's a factor. Okay, and you'll notice it's just a 1 here and a 1 here, because my x squared is just a 1 in the coefficient. Okay, next you'll look at what numbers multiply to -6 and add to -1. Okay, so that would be -3 and +2. -3 plus 2 is -1. -3 times 2 is -6. Okay, and that equals 0. And then you can separate it. X minus 3 equals 0, or x plus 2 equals 0. So therefore, x equals 3, or x equals -2. As in, when we plot this, we'll get a 0 at -2 and a 0 at 3. Okay, so it's important to note another fact, that when we have a times b equals 0, we can say that a equals 0 or b equals 0. But this is only true for the real number 0. When we have something like a times b equals 5, a and b could be anything. A, for example, could be 50, and b could be 1/10. So you have 50 times 1/10, that would be 5. You could even have irrational numbers, such as 5 pi times 1/pi equals 5. So there's an infinite number of possibilities for a and b in this case, and in any case when you have a real number other than 0. But 0 helps to narrow down our possibilities. Okay, that's important to note for a problem like this. So when finding the zeros, we'll first want to multiply this factor times this factor, and then subtract 9, so that we have 0 on one side of the equation. From that point, we could factor again, or we could use the quadratic formula. I'll show you what I mean, but stop short of finding the solution. So first, when you multiply 3x plus 6 times x minus 6, it becomes 3x times x is 3x squared. And then you have 3x times -6, -18x, plus 6x would be -12x, and 6 times -6 would be minus 36. That equals 9. Then you want to subtract 9 to get 3x squared minus 12x minus 45 equals 0. So whether we decide to factor this, if in fact it is easily factorable, or use the quadratic formula, we want to make sure that one side of our equation equals 0. Okay, let's take another look at a problem involving factors. Oops. Let's go back. To this problem. Okay. So we can use what we know about quadratic functions and zeros to help us solve this. So we know that what's underneath the square root must be greater than or equal to 0. So you can treat this quadratic function underneath the square root sort of separately to find the domain. So you'll essentially be looking at where this quadratic function, as in x minus 6 times x plus 5, where that is greater than 0. So what you need to do first is find the zeros. So we have x minus 6 equals 0, so x equals 6, or x equals negative 5. Okay, so that's saying is that we have a 0 at negative 5 and 6. And you'll also notice, it's very important to note, that does this graph open up or down? Well, I've given away the answer. It opens up. But how did I know that? Because the leading coefficient, as in the coefficient next to the x squared, x times x would be x squared, 1x squared. That's my a value in whichever form of the equation, quadratic function you use, as in ax squared plus bx plus c. That's the a there, or in the vertex form, it's the same a, which is a stretching factor. So this a is the same whether you use the ABC form or the vertex form. Okay, so this a, when it's positive, means our graph is opening up. This a, when it's negative, means our graph is opening down. Down, like that. Okay, so from here, we're basically asking, where is this quadratic function greater than 0? Well, it's greater than or equal to 0. So it's equal to 0 at 6, and it's greater than, actually for x values less than negative 5, and at 6. So you see these, for these x values, from 6 to infinity, union, negative 5, we have negative infinity. And they'll ask for inequalities, so as an inequality, it would be something like x less than or equal to negative 5, or x is greater than or equal to 6. Something like this. You might have to enter it a few times to figure out